Hi, and welcome to this quick tool review. This time around, we're going to do something a little bit different than we normally do on the tool reviews, which is just normally look at some tools real quick. This time, I've got a replacement for my Chars 8-inch rotary table. You can see over here, it's a Yuasa, so I was going to take a look at the build quality of this. This guy costs something on the order of $200–300, maybe $3 something range, I forget now. It was fairly inexpensive. This, not so much. This guy was a little over 1,200 bucks, made in Taiwan. I don't know where this one was made, I think China. But if you watch my most recent videos where I was trying to machine a part I had mounted to the rotary table, so there's a lot of lash in the gears here, and you can see the play on the table. That's maybe 100 thousandths back and forth, linear motion, going back and forth here. And so when I was cutting with a big end mill, it would grab and cause this thing to chatter back and forth. Ended up breaking a carbide end mill, had to switch to high-speed steel, and had to run with both brakes on the entire time to eat up some of that lash that was in here. I'm hoping the Yuasa will solve that problem. This rotary table is not poorly made, except maybe the gears. And if you're wondering, over here is a mechanism that allows you to disengage the gears completely. So if I turn it this way, the gears are disengaged and this thing rotates freely, right? So you're thinking maybe I just didn't get this engaged all the way, but that's as far over as it can go and still the same amount of lash. This guy here has this side and this side ground as well as the table ground, and it's a pretty decent finish on here. So what I'm hoping is the Yuasa will improve on that, and they did a better job with the gears, because gears are very expensive if you have them ground as opposed to cut, but they can mesh much better, and I'm hoping that's going to be the case. Otherwise, I spent $1,200 I didn't need to, and next time I use this, got to remember to just run it with the brakes on all the time. I might take this guy apart, see if I can improve on it, but I have some other ideas of how I can use this guy in the future. So let's move on. Let's open the Yuasa and see what the build quality is here for a $1,200 rotary 8-inch rotary table versus a $279 or $300 and something 8-inch rotary table. So I was kind of pleased that this was being delivered on a sort of a cut down pallet. And since it's raining, someone was kind enough to cover this guy in some saran wrap to at least keep water out of it, which is good considering how expensive this was. I was really concerned about that. By the way, if you haven't seen these serrated blades, they're pretty awesome. They cut a lot longer in cardboard than standard box cutter knife blades do, thanks to the serrations. By the way, these Lindstrom dikes are designed to cut hardened steel. You probably can't read it on the inside there, but this is good up for 2mm copper wire and something like 1mm or 0.5 millimeter steel, so you don't damage the tips by pulling out staples even though they're steel. Handy tool to have. So Yuasa is a Japanese company, but they had the rotary table made in Taiwan, which doesn't worry me at all because my lathe, which I really like, is really well made, is also made in Taiwan. So the Taiwanese can make some really excellent tools. I like it. They've got some moisture absorbing paper, some desiccant outside that, and this plastic, I believe, is also absorbing moisture resistant, or at least puts a coating on the contents. I've seen it before. Looks like the packing is really well done with some heavy duty cardboard spacers. There's a handle piece here. You can either do the short handle or the long handle, which is interesting. Didn't know that was an option. Wow, 4 desiccant 4 of these in there. I already can tell that the fit and finish is better on this guy. The ground surfaces are ground more cleanly than the Chars. Looks like they got this at a bit of an angle. Their Yuasa part number placard on the side there. So if you look at how the numbers are printed on the sides, these are very coarsely ground in. Doesn't look like they used a laser, maybe a dot peen tool that's kind of rough. This looks like laser cut on this guy. That's a small difference. The locks are very positive on this. Same exact design. The Chars is a total copy. By the way, the Chars placard came off on its own. They've got these little screw what do you call them? Screw nails, and they kind of popped out on their own. They're very careful to only finish the casting where it really matters on the Chars, which is fine. Same with the dials. I don't know if you can see that over here, but the printing on the dials on the Chars is pretty decent, laser printed, but nicer on the Yuasa. And I got to tell you, the feel is significantly better on the Yuasa. There is a little bit of lash. You can see that there. If I lock this guy off, there's a huge amount of lash, and there's of course all this side-to-side play. And you can see a big gap in here on the rotary dial, and it's not even, it's canted at an angle. Let's see, sorry, right here you can see a big gap in here, and it's at an angle. They didn't care very much, and that's a huge amount of lash. There is a little bit of lash on the Yuasa, but that's to be expected with gears. Let's see, let's take a look at some other features. Let's flip this on its side and see how much side-to-side lash there is. All right, if you look at the ground surface, they're both more or less comparable. I mean, this one's been used a lot, so it's got scratches on it, but it's a pretty decently ground surface. This one is very finely ground surface. They did do a little bit better job, but that's mostly cosmetic. I think functional-wise, they're pretty reasonable. They both have spots for keys to match the ways on your mill. Again, the dials are a bit nicer on this guy, and they certainly fit a lot better. Okay, in order to operate this, guy, I'm going to have to raise it up a little bit because the wheel is taller. Looking at the ground surface on top, the Chars is nowhere near as good as the Yuasa as far as the grinding, how well they ground the surfaces. The Chars is adequate and functional, but nowhere near as nice. However, the Chars has a ground Morse taper 3 in the middle, and this guy feels like it was just machined, not ground. That's kind of interesting. I'm really surprised. That's a little weird, right? You'd expect it to be at least as good as this guy, but definitely not. Let me go grab Morse taper 3, see how it fits. So in the Chars, this guy fits so well that if I drop this, it'll be stuck in here, and I'll have to pop it out on the bottom. Oh, okay. This one goes in further and is a good fit. Even though it doesn't look like it's ground, it looks like it's only machined, whereas the Chars, they actually went to the trouble of machining it. Point to the Chars for that one. Interesting. This one does fit really well, however. The gears are so tight that it feels like, relative to this one, feels like there's brakes on all the time, which they're not, because they mesh so well. There's more resistance when you rotate it, but there's no lash at all here. I wouldn't have had the problem with this one that I had with this one. Again, and nothing. Can't make it do it. This also has the release, so this is disengaged, and then this guy can freewheel. And that is fully engaged. And we are back with 0 lash. This one, loosen this up. That's off. Freewheeling. That's engaged fully. Locked. And lots of lash. So the most important feature of why I upgraded and paid the big bucks was better gears on the Yuasa. The lack of lash on the table means I won't have to run with the brakes on all the time. And so that's a huge improvement. As a bonus, I get a better ground surface on the tabletop than the Chars, but the Chars was plenty adequate. Alrighty, so I want to look at a couple other measurements. One, I was going to measure and just see how, when this is rotating, how one particular point stays flat. And then I was going to just go over the surface and see how flat that was. This is some Suburban Tools 246 blocks so that I can actually rotate this while it's up. But you know, they're flat and accurate. They're brand new. I got a really good deal on eBay on those. Those were an awesome find. Shiny, smooth bits of metal. Love them. Anyways. I'm going to get an indicator on this guy. We're going to measure this one first, and then we're going to check out the Yuasa. This is supposed to be every bit as accurate. I wonder about that. So let's just move forward, take a look. All right, so let's rotate this guy. Hopefully I can block the glare from you. These are tenths, by the way. Each full digit is 1,000th. This is a tenths indicator. So in this segment, that's really good. Towards the end here, I think because I've tightened blocks in here, this may have leaned up a little bit, but this is a couple tenths high as I get to the slot here, or maybe it's motion as it's been cut in the past. Yeah, as you get away from the T-slots, it tends back towards the 0 point. And then, oh, that one didn't go up. This one didn't go up, it stayed down. You know, it's better than 1,000th towards some of these here. And that sort of speaks to the bearings a little bit too, that because it is, as it rotates, it's not varying. It means the bearings are at least sitting flat here in this section. Okay, let's see how we can do here. So let's see what it is from the edge. Doesn't change much as I push on it, which is really good sign. So close to 0 there. 0, down 2 tenths. Oh, what has happened is I'm actually hitting. I need the tip to stick, the probe to stick down a little more. You want it to be as parallel as possible to be accurate, but I'm actually rubbing the bottom of the dovetail here on this surface. Okay, we're at plus 1/10 here. Let's go in towards the middle. We're down 4 tenths. Down 5. 6. 7. But relative to itself, pretty good. So there's a little bit of droop as you go towards the center, and this is the Chars. It's actually pretty darn good. Oh, there's a higher spot, 4 tenths. Let's see what happens when I come back. 4, 3, right on the money. A little bit down, and pretty close again. All right, so this one's not bad. It's not bad at all. Probably about 1,000th maximum variation between all the different points here that I've looked at so far. Now let's take a look at the Yuasa, see how it does. All right, let's take a look at the Yuasa. One thing I will say about the Yuasa is that it has a lot more force to rotate it because I think the gears mesh so more tightly, which stops you from having the lash problem the Chars has. But it makes this a little more challenging because it's not held down at all. When you're measuring tenths, stiffness is a really big deal. And I just want to make sure this thing's not changing. So there we are at 1.5. I got to hold this down as I rotate this. So that was like in the center there. And it came right back down. So it went like up a tenth or a tenth and a half, and then down a tenth right here. Let's see what it's like going in towards the center. So I'm going to rotate this back towards the high spot here. And let's see what we have. I'm going to re-zero this. I didn't really want to use my height gauge to do this because when you're dealing with tenths, the height gauge is not a great way to, you know, hold tenths because it's got a lot of flex in it. But I really had no choice because I didn't have any indicator holders I could get up this high. I could probably have saved these 246 blocks and put the height gauge on that or something, but I hate stacking because then you're stacking error potentially. So we're here at 2/10. There's 0, 0, 0. Let's see, can we reach that? 0. Let's come back. 0 or minus 0, 0, 0. So I'm always worried when you're pushing the indicator up because you kind of flex everything and they don't always come back the same. So we're looking like less than a tenth difference from inside to out. As you could see there, it's sort of coming back each time. That's pretty impressive. That's much better than the Chars that dips in the middle. Just for the heck of it, how does the center section do? You'd think the indicator was broken. Ah, there's a tenth. Which also could be related to the fact that I'm dragging the indicator sideways. See, as I push the indicator side to side here? I prefer to have them move tangentially. Wow. If you didn't know any better, one might think that I was cheating on this. So clearly the flatness is much, much better on the Yuasa. So that's another thing you're paying for right there besides the better paint job. Although there are some drips here, but I'm just kidding. All right, so I wanted to see how perpendicular this was ground. This is the Chars, and then I've got the Yuasa down here where you can't see right here. This is a Square Master, so I set it up with a granite square, and it's less than a tenth all the way from the bottom to the top. And I know you can't see the indicator. I could flip it around, but anyways, as the indicator travels from here to here, it's less than a tenth. So we're going to compare that and look at this guy over here and see it's sitting on the 246 block again, and we're going to see how perpendicular it is to the face. I'm kind of curious about that. Not a common measurement for me to do, but what the heck, right? Dealing with tenths, everything is so persnickety. That's a tenth top to bottom. That's very impressive. Yuasa's not going to be able to beat that. The Yuasa is about 4/10 from top to bottom. That's surprising to me that it would be off, but yeah, 5/10, half a thou. Wow, I'm genuinely surprised. It makes me wonder if there's like a burr or something I didn't clean up. I did stone the bottom of this guy. Well, kudos to Chars there. Take a look at this a little more, see if I can find out, I mean, if it's actually just ground a little off or what. Well, that's it. The Yuasa went on my shelf. The Chars is going to go elsewhere. I have some ideas for what I want to possibly use this guy for in the future, so follow my channel. and you might get to see. Hopefully this can be modified to work as a rotary grinding fixture on my surface grinder, which is what I'm going to do. I'm not going to waste this guy. It's a lot heavier built than it needs to be for that particular project, but you know, I've got it, so why not use it? In any case, thanks for watching. Hope you find it useful. Hope to see you next time.